So, good morning, students. In the last class, we have started with the cutting fluids, coolants, and lubricants. In that, we have finished what is cutting fluid and coolant and lubricant, right? And what are the types of cutting fluids and, and selection of cutting fluids and advantage and disadvantages of cutting fluids, right? Now, we are going to discuss some of the methods using the cutting fluids. There are three types of methods. In that, flood method is there. In this, a reciprocating pump is used to force the coolant over the workpiece and tool. The outlet of the pump is connected to a nozzle through a flexible pipe. Why we are connecting a nozzle means it converts pressure energy into kinetic energy. That means velocity is increases coming from the nozzle. The nozzle can be adjusted to direct the stream of the fluid into cutting zone. This is the most common method of application of cutting fluid. So this is the flood method. In this, we are using a reciprocating pump used to force the coolant over the workpiece and tool. Generally, we are using the coolant to reduce the heat, right? And outlet of the pump is connected to a nozzle through a flexible pipe, and the nozzle can be adjusted to direct the stream of the fluid at cutting zone. And this is the most common method of application of cutting fluid. In the diagram, you can observe the cutting fluid application. The white color is the coolant, right? And it is forcefully uh, injected on the cutting zone to reduce the heat affected. Now coming to the another method, jet method. In the diagram, you can observe easily, a small jet of fluid at high speed is directed at the point of metal supporting from the underneath. Observe here, application of cutting fluid. A small jet of fluid at high speed is directed at the point of metal supporting from the underneath. So metal supporting ekkadunno akkadi నుంచి మనము we are injecting the jet. In high speed jet system, gear or vane type of pump is used to maintain high pressure. So this is the jet method. This is the nozzle. So this coolant is directly injected into the cutting zone. In the diagram we are observing, we can tell that it is a drilling operation because we have observed here a drill bit, right? The coolant is injected on the cutting zone. Next, mist method. The fluid is passed through a specially designed nozzle to form very fine droplets, that is mist. This mist is directed to the cutting zone at high speed. It has better cooling effect than flood or jet method. So mist method, what is happening here? The fluid is passed through a specially designed nozzle to form very fine droplets, small droplets. We can call it as a mist. And this fine droplets is directed to the cutting zone at high speed. It has better cooling effect than flood or jet method. Right? So these are the three methods. By these three methods, we are using the coolants on the cutting zone. Flood method, jet method, and mist method. Okay. And coming to the next topic, that is lubricants. A cutting fluid which is used for the purpose of reducing friction between the contacting surfaces in the cutting zone is called lubricants. Here, the coolants are reduces the heat effect, whereas the lubricants are reduces the friction between the contacting surfaces. Where the contacting surfaces are reduced and where the relative motion is existed between the two mating parts, then we are using the lubricants to reduce the friction effect. Due to this friction effect, heat is increases, heat affected zone is increases. Due to this heat effect, there may be damage of metal parts. So that's why we are using lubricants. So it is also a cutting fluid. It is used for the purpose of reducing the friction between the contacting surfaces in the contacting zone is called lubricant. Lubricants help in reducing the heat generated during machining processes. So due to mating parts and there is a motion between the parts, there may be a friction develop. So we are using lubricant at that point. So due to this lubricant, we are reducing the heat generation. So observe here two mating parts, gears. These are two gears. Here the motion is transferred from this gear to this gear. Okay. So here a contacting surface is occurred. So while transferring the motion, there is a friction developed because of this metal to metal contact. So what we are doing here is we are applying lubricant at this zone. At this mating zone, we are applying a lubricant. So because of this lubricant, there is a reduction in friction. So due to this reduction in friction, we are reducing the heat also, heat generation also. So due to this heat generation less, we are increasing the metal life. Okay. So so machine tools such as lathes, milling, drilling, shaping perform satisfactorily if they are properly lubricated. The parts of machine tools which need lubrications are slideways. On this slideways, tailstock is moved, right? So the contacting between the metal to metal, we are using lubricant. And gearboxes, in the earlier diagram, we have observed there is a contact surfaces between the two gears. At that contact point, we are applying lubricant. And spindle is a rotating element. So it is rotated on the uh, shaft. So due to this, there may be a friction developed. So we are applying lubricants. And bearings. Generally, we are using bearings for reducing the frictional effect. In that bearings, we are using lubricants. Understood? Bearings are generally used for reducing the friction between the two rotating parts. In that bearings, the main element is lubricants, okay, and mating parts. So these parts are needed, the lubrication, slideways, gearboxes, spindles, bearings, and mating parts. And what is the purpose of lubricants? We know already, to reduce the friction between cutting tool and the material being cut, and to minimize the heat generated during operation, to prevent rise in temperature, and to reduce wear. Okay, so these are the purposes we are using. Mainly we are reducing the friction between the two mating parts, and we can reduce the heat generated during the operation. If the friction is reduces, automatically heat generation also reduces. And also rise in temperature, if the heat generation is less, rise in temperature is also less. And wear also reduces. And increases the tool life, provide cushioning effect against vibrations, to drive away chips, scale, and dirt between the mating parts, protect the finished surfaces from corrosion. So next, properties of lubricants. So if one of the element is called as lubricant, it has to possess these following properties. One, viscosity, there is resistance to flow. And oiliness, flash and fire point. So a flash and fire point means it does not burn quickly. Pour point, freezing point, chemical stability, carbon residue. So these are the properties has to possess the lubricant: viscosity, oiliness, flash and fire point, power point, chemical stability, carbon residue. Viscosity, we can discuss one by one. It is the measure of resistance of the oil to flow. We know already viscosity, it is the measure of resistance to the flow. If the oil is used as lubricant, must have sufficient viscosity that it is not squeezed out from two surfaces. If the viscosity is less, that is resistance to flow is less, it it does not appeared on the surfaces. It is easily washed away from the two surfaces. So some point of viscosity should be there. So due to that, the resistance to flow is high. So the oil does not flow from the two surfaces. If the oil is used as lubricant, must have sufficient viscosity that it is not squeezed out from two surfaces. Oiliness. The ability of the oil to wet the metallic surface is called oiliness. So it should be wet the metallic surfaces. Lubricants with good oiliness prevent the breakdown of the oil film and reduce the wear. Next, flash and fire point. Flash point is the lowest temperature at which an oil gives off sufficient vapor to support momentary flame. Fire point is the temperature at which an oil gives vapor to burn it continuously when ignited. Flash and fire point should be high for lubricants, because why we have to maintain it should be high means, because lubricant is applied at mating parts, right? So due to this mating parts and the moving parts, there may be increasing the friction. Due to this increasing the friction, heat generated is more. Due to heat generation, temperature rises. Due to temperature rises, the lubricant may be fired. So due to this reason, flash and fire point should be high. Flash point is the lowest temperature at which an oil gives of sufficient vapor to support momentary flame. And fire point is the temperature at which an oil gives vapor to burn it continuously when ignited. So should be high. And power point, this is the temperature at which an oil will cease to flow when cooled. It indicates the suitability of lubricant for use in cold conditions such as in ice making machines, refrigerators, etc. Chemical stability. The lubricant must be chemically stable and must not oxidize easily. It should not be vaporized under working conditions and should resist corrosion. At high temperature, lubricating oil decomposes and deposits free carbon on the surfaces. A good lubricating oil should deposit small amount of carbon, that is low carbon residue, at high temperature. So these are the properties of the lubricants. So we have completed properties of lubricants, right? And what is lubricant and purpose of the lubricants, right? So classification of lubricants. Liquid lubricants, that is animal oils, vegetable oils, mineral oils, synthetic oils, and semi-solid lubricants in that, and solid lubricants that waxes. So we are having three types of lubricants: liquid lubricants in that, animal oils, vegetable oils, mineral oils, synthetic oils. And next, semi-solid lubricants, that is grease. Solid lubricants, it is also grease and waxes. These are the types of lubricants. In that, first we are going to discuss about the animal oil, that is tallow oil, lard oil. They are obtained from animal fats. Tallow oil is used in cold drying operations. Next, vegetable oils, that is castor oils, olive oils, rapeseed oil. These are extracted from seeds and trees. Castor oil is used in automobiles. We generally using this. And animal oils and vegetable oils are not widely used in machine tools since they get oxidized easily, because these are exposed to, when we are using on machine tools, it is exposed to the atmosphere. Due to this exposure, they can easily get the oxidized. So for this reason, we are not using animal oils and vegetable oils in machine tools. Okay, animal oils are coming from the animal fats, and tallow oil is used in cold drying, and vegetable oils are coming from seeds and trees. Next, mineral oil. Animal oils are tallow oil, lard oil, okay, and vegetable oils. So animal oils are obtained from animal fats and it is used in cold drying. Vegetable oils are coming from seeds and trees, and castor oils are used in automobiles. Generally, animal oils and vegetable oils are not widely used in machine tools since they get oxidized easily. Mineral oil. These oils are petroleum products and are most commonly used because of their cheapness and stability. They do not form emulsions with water. This means it is not mixed with the water. Mineral oils are not mixed with the water. So if the oil is mixed with the water, it is called as a emulsion. But here, mineral oils are not mixed with the emulsions. Next, synthetic oils. Synthetic lubricant. Polyalkyl glycol and silicon fluids possess good lubricating properties. The high cost limits their applications. Okay, so these three are under the liquid lubricants. Next, semi-solid lubricants. Grease forms an important semi-solid lubricant. Generally, we have observed used when the fluidity of oil is undesirable. It is an oil which has been thickened by soap. Semi-solid. It offers simplest method of lubrication with additional advantages of preventing the entry of dirt. In automobiles, they are used where high temperatures are encountered. Advantages with semi-solid lubricants. It is particularly suited to bearings at slow speed and large clearances. It provides seal against dust, grits and moisture. It provides constant lubrication for a longer period. In ball and roller bearings, grease lubrication is invariably used. Disadvantages. Grease provides very little lubrication until the bearing temperature rises sufficiently to melt it. And solid lubricants are used where oil film cannot be maintained due to high pressure or temperature. Graphite is one of the best known solid lubricants. These are used in high temperature services. These are not suitable for ball and roller bearings. And the last one is waxes are derived from petroleum. They are compounded with fatty acids and soaps. They are used under high pressure applications used during drawing, rolling, extrusion operations. Waxes are derived from petroleum and these are compounded with fatty acids and soaps, and these are used under high pressure applications used during drawing applications, rolling and extrusion. Okay. So those are the types of lubricants. Now, lubrication of machine tools purposes. Machine tools give satisfactory performance if they are properly cleaned and lubricated. Slideways, gearboxes, and spindle bearings must be lubricated to minimize friction. Generally, we have observed up to now in lathe machines, shaping, cleaning, slideways, gearboxes, and spindle bearings must be lubricated to minimize friction. Lubrication of slideways protect the surface from the wear. If the mating parts are well lubricated, the movement of slides will be precisely controlled. Ball and roller bearings are lubricated to minimize the friction and to protect them from rust and wear. Lubricating oil is generally applied to sliding parts with the help of oil can and are also applied by the following systems: gravity feed system, pressure feed system. So a grease gun we have observed. In this gravity feeding system, lubricating is applied to the sliding and mating part through oil cups. The oil cups are located at higher levels of sliding and mating parts. In this system, oil flows to the parts due to gravity. So in this, we are pouring the oil, and the oil is going to the mating parts because of the gravitational effect. So this is gravity feed system. Next, pressure feed system. In this pressure feed system, we are using automobiles. Lubricants are applied under pressure by using oil pumps. Oil pumps is situated below the engine, right? So these are the lubrication systems, methods of lubrications and purposes of lubrication, right? So with this, we have concluded the fourth unit, that is cutting fluids, coolants, and lubricants. Thank you.